I review one paper with the title Enhancing Energy Detection with Optimized Canny, Hough, Transform, and Machine Learning. The reviewer is Abraham Pyongyang Pyo. So in that paper, I found things that need to be correct and things that are correct. So by far we are going to look what is the paper proposing. And I found that the paper is proposing hybrid 5. So, and these are the steps that I'm going to explain here. So in that paper, we found the problem is traditional candy is noisy, Hough transform, miss the broken ended. So in that paper, a writer proposed a solution, a step hybrid approach. So, and after proposing that approach, he also optimized candy, bilateral filter, preserves endage, and plus flower pollination algorithm, that is outer turns threshold, and you can find the figure in figure 2 in the paper. So, and the third is Hough transform detects lines between the broken endage and experiment with max bot value, which is 5 and 7, 9, 12. And also you can find that in the figure 3. Then machine learning with the method. We have random forest, neural network, and refined endage classification using the 36 extra features. And the results were best, which is the accuracy is 88.47%, and visualization inside a simple flow chart. Box 1, which is image 1, box 2 is optimized candy, box 3 is Hough transform, and 4 machine learning. Finally, the endage. So within that paper also, there are things that are well done in that paper. So, and one of them is the adaptive threshold, which replaced manual candy turning with flowers pollination algorithm, which is more objective. And then we have endage preservation, bilateral filter, reduce noise without blurring endage. Also, we have robust to broken endage through Hough transform successfully connect the endage firmament into a full line. And we also have the rich feature set, 36 features pixel, neighborhood segment, provide a comprehensive endage context. And we have balanced ML performance, achieve the best trade-off between the precision, which is 29.8, and recall it 38.6 compared to the RF and also in this paper there are gaps, or there's gaps that need to be filled. These are the critical weakness and missing element in the paper. There's low overall of matrices. Price is great, precision is than 30%, and economy is less than 40%. They are too low for the real world use, like you cannot use in medical field or everyone is called. Also, there is no frequency domain process, missing Florent wavelet transformation, and only subtual domain. There's limited shape detection. Hough transform only detects lines, no cycle, no eclipse, or no cap. There's no caps that are also detected. And there's also a small data set, only 50 images from BSD, no testing, no on noisy or real world industrial image. And also there is no computational analysis, no runtime or hardware comparison between best traditional candy. There's technical error, and there's also poor visualization in the paper. So these are some of the recommendations that I can give to the writer. So a writer should work on he should also fix the matrices, uses class weighting or SMOT to boost the recalls. And he should also add the frequency domains that include the Florence, IPAS, and filtering before Canny. He should also add HT, implementing circular and elliptical odds transform. And another one is you should also expand the data at least to 500 as BSD. And the list, which is not the last, you should also add ablation to remove each of the components to see the contribution. Lastly, you should correct the errors, fix the equation 2, and improve the figure 4. So to conclude it, actually the hybrid approach is promising, but it is not that productive. And we should also require a better precision or recall frequency, the domain method and large validation. With all the correction, it could become a robust solution. So that is the little presentation that I have prepared. So thanks. If there's any comment, any question, then it's loud. Thanks.